The next application I would like to talk to you today is the Leotief input-output models. In 1936, American economist Leotief published a model concerning the output and input of an economic system. In 1973, Leotief received a Nobel Prize for his work in economics. So now, let's consider an economic system that has n different industries, I1, I2, and I3, each having input needs, namely raw materials, utilities, etc., and an output, which is finished product. In producing each unit of output, an industry may use the outputs of other industries, including itself. For example, an electric utility uses outputs from other industries, such as coal and water, and also uses its own electricity. Now let the Ij be the amount of output the J industry needs from the I industry to produce 1 unit of output per year. The matrix of this coefficient is the input-output matrix, so the column will be the demand. The demand of the first industries, second industries, and the nth industries. The row will be the supply. So the first industry will supply to other industry, the second to others, and the n to other, and then you will receive the square matrix. And now let's move on to the example how to form an input-output matrix. We will consider a simple economic system consisting of 3 industries: electricity, water, and coal. Production or output 1 unit of electricity requires 0.5 units of itself, 0.25 units of water, and 0.25 units of coal. Production of 1 unit of water requires 0.1 units of electricity, 0.6 units of itself, and 0 units of coal. Production of 1 unit of coal requires 0.2 units of electricity, 0.15 units of water, and 0.5 units of itself. Find the input-output matrix for the system. Alright, so our matrix will be D. The column will be the demand. The demand of the electricity, of the water, and of the coal. The row will be the supply. Supply of electricity, supply of water, and supply of coal. To produce 1 unit of electricity, the demand is 0.5 units of itself. So here 0.5. 0.25 units of water. 0.25 units of coal. Production of 1 unit of water requires 0.1 units of electricity, so the demand of water from electricity is 0.1. 0.6 units of itself, and 0 units of coal. The demand of coal is 0.2 from electricity, 0.15 from water, and 0.5 from itself. So then you will receive the input-output matrix of the system. The column entries show the amounts each industry requires from the other and from itself to produce 1 unit of output. The row entries show the amounts each industry supplies to the others and to itself for that industry to produce 1 unit of output. And now let's move on to the next definition, the closed system. Let the total output of the art industry be denoted by Xi if the economic system is closed. That is, the economic system sells its products only to industries within the system. Then the total output of the art industries is divided by the formula number 5. Alright, so now let's consider the first industry. So then x1 is equal to d11 x1 plus d12 x2 plus etc. plus d1n xn. So x1 is the total output of the first industry to produce x1 units. The first industries must require d11 times x1 from itself, and so the total output of the first industry will be xi. Alright, so now let's consider the first industry. x1 is equal to d11 times x1 plus d12 times x2 plus etc. plus d1n times xn. Alright, so x1 is the total output of the first industries. The first industry have to supply d11 times x1, and the first industry also supply to the second industry the amount d12 times x2, and the first industries will supply the end industries by an amount d1n times xn. So then you will receive the total output of the first industries. So the first industry must supply to itself and to another industries. Similar, you can find out the total output of the other industries. Alright, so now let's consider the open system. If the industries within the system sell products to non-producing groups, such as governments or charitable organizations outside the system, then the system is open, and the total output of the art industries is defined by the formula number 6, where EI represents the external demand for the art industries products. So here you can say, let's consider the first industry. The total output product the first industries must produce is x1. The first industries will provide d11 times x1 for Excel, and d12 x2 for the second industries, etc. d1n xn to the end industries, and E1 the external demands for the first industry's product. And then we will receive the system. The collection of total outputs for an open system is defined by the linear system. In the matrix form, we have the system number 7, where X is the output matrix and E is the external demand matrix. Now let's move on to example. An economic system composed of three industries has the input-output matrix. Find the output matrix X when the external demands are E. Alright, to solve this problem, you just write down the matrix equation. From here, you can find out vector X, which is the total output. So, to produce the given external demands, the output of the three industries must be approximately 46,616 units for the industries number 1, 51,058 units for industries 2, and 38,014 units for industries 3.